Hi, my name is Saeed Al-Hallaj. I am the founder of All Cell Technologies and the visiting research professor of chemistry at the University of Illinois Chicago. I will be talking today about topic of my presentation will be on the recent development of lithium-ion battery pack deficit. Let me just put this in full mode. So the overview presentation is probably going to be around covering some of those topics related to history and future technology about lithium-ion batteries mainly. We'll talk about some of the electric mobility applications and some of the key improvements and cost reduction. And then we're going to probably focus more time on thermal management safety challenges, go over some of the current solutions, and give some focus, some information about the past thermal management we developed at All Cell with phase change composite. I will give a couple of case studies just for illustration, and then we'll conclude the talk. This big picture overview of the energy challenge transportation sector focus on the current problems that we solely dependent on fuel from oil derived products or liquid fuel products, hydrocarbon products. This is mainly due to the domination of the combustion engine for this type of transportation, mechanical drivetrain system. The main revolution or the main transition to clean energy or zero emission type of transportation technology has to go through electrification of transportation sector. Basically, we will see gradual transition toward electric drive system or power system that are powered mainly by electrochemical systems such as batteries, ultra caps, and fuel cells. Some of the major challenges that has been facing that industry, mainly the automotive industry over the past, actually not years, but decades, is still related to the energy storage, which mainly batteries are still expensive, they don't last long, you need higher drive range or energy capacity. And recent development of lithium-ion batteries are promising, but as we will see in this, probably in the next few slides, that we're still not there. There's some major challenge that need to overcome. There is other technology in the horizon, mainly fuel cell and hydrogen. Still, hydrogen cost, durability, performance are still issue. And the hydrogen infrastructure are still not there, which probably these are some of the big bottlenecks on the hydrogen economy. Just to be clear, infrastructure is a matter of investment, but hydrogen storage on board is a major technical barrier that needs some major discoveries, material discoveries in order to be able to find a way to store hydrogen on board vehicles that allow us to drive 300 or 400 miles, similar to today's liquid fuel technologies. Here's some of the announcements that we've seen recently from the automotive industry and even countries that are either going to ban or phase out very soon combustion engines or polluting technologies. And as we have seen major announcements by companies like GM, Mercedes, and others who basically either going to transition completely to EV or electric drive systems in the next few years, or start by introduction of several models and then slowly transition and phase out combustion engine-based kind of mobility systems. This is kind of just to give an idea, and I'm not going to dwell on it, but electrification has been happening for the last 2 decades with what's called hybrid or micro-hybrid, which is basically a stop and go, start and stop battery that powers the auxiliary power in your vehicle when you're stopped at a traffic light. It does not have anything to do with the drivetrain, all the way up to fully electric systems that are 100% powered by batteries or fuel cells. In between, you'll see something of hybridization, something like a mild hybrid where the battery carries a few miles or assists in the drive, or to plug hybrid, which is a fully electric system that has a battery that drives you for the first 20 up to 40 miles. And then after that, you have a combustion engine or a small engine acts as a power generator in the trunk of the vehicle to power you till you charge the battery or go to the next gas station, for example. It's important to notice that while fully electric system can lead to significant improvement in environmental emissions, depending on the source of energy they use to power or charge the vehicles, micro-hybrid systems are very effective in improving the miles per gallon, the efficiency by a few percent at a very small cost without major change in the power drive system or the way the vehicles are made today. Here's some examples of the various models that have been introduced in the past few years, and you'll see more and more of those technologies. As you can see, at the core of those is the battery technology, and this is where most companies are rapidly either investing internally by vertical integration or by partnering with other companies to help them with tackle those problems. For example, we've seen major partnerships such as the Tesla with Panasonic and GM with LG, and you'll see more and more of those as we go along. This is kind of, let's call it, kind of the Achilles heel for the lithium-ion batteries. When you go beyond automotive transportation to other challenging applications such as electric vehicle takeoff and landing planes, electric planes, or even some commercial drones, electric boats, or even autonomous vehicles, you'll see there's a combination of technical requirements that are needed to meet those requirements for these type of applications, which are mostly autonomous. Now, to do that, you need a combination of high specific energy and power, which means you have very energy density, and at the same time, ability to extract high power, for example, in takeoff and landing for those electric vehicle plane, or acceleration in the case of sport kind of application. However, for all these applications, that safety is at the core of that. And more we will see emphasis on safety of lithium-ion batteries that probably will be the determining factor whether these kind of batteries go into wider application or be limited to specific areas as long as this problem is at forefront. This is just a rough roadmap. This graph probably is not new. It's been floated around several times. Basically, we look at it, the bottom line is lithium-ion batteries still dominating. We're going to still see more improvement. The industry has been doing very well over the past 2 decades of continuous improvement of 5 to 10% on the energy density, continuous cost reduction, but also they have managed to improve the power delivery or the power density by a combination of new electrode designs or edited materials, and also by increasing the engineering of the pack and the cell by tapping and bus bars and advanced power electronics. However, even with lithium-ion batteries, the liquid or gel type of electrolyte is still a problem, and that's probably the root cause of a lot of those safety issues. And to solve that problem, solid-state batteries has emerged as a solution. Basically, instead of have a gel or liquid electrolyte that is soaked in the polymer to conduct the ions, you'll see a fully solid polymer that actually is conducting the ions. And that's going to be a major challenge, especially at the room temperature. We've seen a lot of progress. We expect that to continue, but I doubt that we will see any high volume or large application for automotive or other big tens of kilowatt hours or megawatt hours of batteries in the near future. It's going to take more than 5 to 10 years to do that. In the meantime, you will see technology beyond lithium that are focused